All right, guys. Sorry, I am not here today. Friday, my dad had a pretty major surgery done. He's still in the ICU, but my son is sick now. So if I'm not here, it's because he's sick and I can't send him to school. But I'm going to give you some notes here, make you focus on a few things. You're going to definitely need to write some things down, pause the video, and write this information down. This first slide right here is called the compound interest formula. Okay, so you're going to notice, and so pay attention to the words here. Where I have A equals P parentheses 1 plus R over N to the NT power. P is still our principal. R is still the rate, and we're going to write it as a decimal. N is what it is new here. It's going to say compounded continuously, or compounded quarterly, compounded monthly, compounded daily. This value of N is going to change. Okay. And then T is the number of years, and this number would be the account after that many years. Okay, so I want to look at an example here. I want to make sure that you have this formula written down, and you should be able to tell me what every single one of these formulas is. So this first example says Tamira invests $5,000 as an account that pays 4% annual interest. How much will there be in an account after 3 years if the interest is compounded annually, semi annually, quarterly, or monthly? Okay, so first of all, we have this formula right here. Y equals A times 1 plus R raised to the T power. This was the formula that we talked about in 6.1. And then this formula is Y equals A times 1 plus N over, R over N raised to the NT power. Okay, the rate goes on top. We're dividing it by the number of times compounded. So let me write that just a little bit neater so I can come back to that. Okay, there we go. Okay, so this is the R power over N. Okay, notice N is twice in this. So there's going to be four different formulas that we're going to write. First of all, compounded annually. Okay, well, annually means one. So one time is, if I put a 1 in here, R over N is just R. If I put a 1 here, 1 times T is just T. So if I do this annually, I would have Y equals, so annually will be Y equals 5,000 times 1 plus my rate, which is 0.04, all raised to the third power. Type this in the calculator. We'll do that in a second. Okay. Semi-annually. Now I have a, learn to work on my spelling here. Two N's. Okay. So semi-annually. Now I have an N. So it's still 5,000 is my initial amount times 1 plus 0.04 all over 2 raised to the 3 times 2 power. Now you're going to notice that I put this in parentheses. That's because when I put this in the calculator, I want to make sure that both of those numbers are an exponent. Okay, quarterly, we should all know what quarterly means. Quarterly is 4, so Y equals 5,000. That's still the initial amount times 1 plus 0.04. That's still my rate, but we're going to divide it by 4, and we're going to raise it to the 3 times 4 power. Okay. So again, you're going to notice that all this stuff is almost identical. I'm just changing my N based on what I'm given, and the last one would be monthly, and that would be Y equals 5,000 times 1 plus 0.04 all over 12. Running out of room here. All over 12 raised to the 3 times 12 power. Okay, and you're going to notice on this next slide, all of the math is done for us. Okay, so you notice as it's compounded more frequently, the value gets larger. Okay, so again, know this formula. Make sure that you can enter this into the calculator. I'm going to show you how to enter it on this next example. So this slide right here has all the solutions. You can go and check and enter those into Desmos or your handheld calculator. Make sure you're coming up with the correct answers. We'll do one more together where I've got Y equals 3,000. That's the initial amount, okay, times 1 plus my rate is 0.03. The number of times compounded is monthly, so that would be 12. All raised to the 12 times 10 years power. Okay, so this is what you have to be able to set up. And then now you have to make sure that you can enter this into Desmos. So when I go to Desmos, I have, come on, see if it'll work for me here. There we go. Okay, I've got 3,000. Notice I don't put y equals. Raised to the 1 plus, I'm going to hit the division bar so that it gives me a fraction. That would be 0.03 over 12. I'm going to close that parentheses. I'm going to raise it to, and I'm going to put in parentheses 12 times 10. And this would be my answer, $4,048.06. Okay. So again, you should be able to type that into Desmos. All right. Next type of problem deals with a brand new number. Okay. This new number is E. So we have something that's called the natural base E. That's from Euler's number. And it comes from this formula here, but I don't need you to focus on this formula. I just need you to know that anytime you see E, it equals 2.71828, blah, blah. It's irrational. Okay. So it goes on forever and ever and ever. So we have a new formula, and that is when it is said to be compounded continuously. In the word problem, it will say compounded continuously. So the nice thing is P is still P. It's our principal. It's the starting amount. E is the natural base. R is my rate. And T is my time in years. So we're going to look at a problem here, and this is what you have to make sure you pay attention to. This problem says Regina invests $12,600 in an account that earns 3.2% annual interest, compounded continuously. This right here tells me that I'm going to use this formula, also known as the PERT formula. Okay, so I've got 12,600 as my starting amount. What's going on with my pen? Hold on. As my starting amount. Sorry about that. Let's erase that. All right. So I've got 12,600 as my starting amount. E is a number. 0.032 is 3.2%. And I want to find that value after 12 years. So again, I always put those two numbers in parentheses there. So I go to Desmos and I'm going to enter this into Desmos. I've got 12,600. E, I literally just type in E, raised to the, I'm going to put in parentheses, 0.032 times, I think it was 12 years, right? Times 12. So a lot of calculator problems. That would mean I'd have $18,498.63. Make sure we're rounding correctly to whatever they tell you to round to. Okay, so yeah, it was 12. Okay, and then the last thing that I'm going to have you do is to write an exponential model. So when we're writing an exponential model, there are two things you have to do. Number one, we have to fill in a blank table in Desmos. Okay, so whatever I have here, if it's one order, two order pairs, three order pair, I will put them into a blank table. And then the second thing I'm going to do is I'm going to type in Y1, the little tilde. I'm going to type in A, B, all raised to the X1 power. Make sure that you use that Y1 and the X1. So again, my two ordered pairs are 7 130 and 8 240. So I'm going to go to Desmos again. And in Desmos, I'm going to get a blank table by hitting the plus. I'm going to type in 7 and 130. Right? That was my ordered pair. That's the first ordered pair, 7 130, and then 8 240. So then 8 240. So here's my two ordered pairs. And then I'm going to, in the next slide down, I'm going to type Y1. I'm going to hit the little tilde. I'm going to type in AB, and I'm going to raise that to the X1 power. You'll notice when I do that, this gives me my A and my B. So I'm going to go ahead and copy and paste this over to my PowerPoint and show you what the answer should look like. Okay. So then now, when I get this in from Desmos, I'm going to make sure I read Savas and make sure that I round it to what they tell me to. They normally tell you to round to three places. So I'm going to have Y is approximately equal to A would be 1.77. This 5 is going to make that 8 a 9. So 1.779 times, and then I put in the B, 1.846. The 6 stays a 6 because the 1 doesn't move it up, and that's all raised to the x power. So really simple stuff, pushing a lot of buttons, using a couple of new formulas. Please, please, please do the assignment. There's only 12 questions. You should have no problem getting this done before you head down to the job fair. Okay. Again, sorry I'm not here. I hope you guys have a great day. I will see you Thursday. I will definitely be there Thursday.